Hello. Let's take a look at projectile motion if I give you an initial velocity. In our last video, we took a look at a projectile motion problem where you started given the components, the vertical and the horizontal components. In this example, we're going to need to take apart an initial velocity to find those components. You know how to do that using your vector skills. Here's our example. Let's solve this, and then after we're done solving it, take it apart and see what we did. So an arrow is launched with a velocity of 50 meters per second. So this is our initial velocity at an angle of 60 degrees above the horizontal. So this here is a theta, an angle. How far does it go? We're looking for a horizontal distance. So the idea here, just sort of sketching out what we've got, I've got an arrow that's following a path like that. This time, I gave you an initial velocity and an angle here like that. So we need to figure out the vertical component here, our initial vertical velocity, as well as our horizontal velocity. Figuring those two out, we need to decompose this vector. So what I have is I have a little triangle. I'm going to draw this out. This is not to scale. I have 50 meters per second is my hypotenuse here. This is my VVI, and that's my VH. I know that that is 60 degrees. There we go. I need to now figure out these two. So my vertical velocity, my initial vertical velocity is going to be 50 sine 60, which works out to 43.30 meters per second. My horizontal is the adjacent, so that's 50 cos 60, which works out to 25 meters per second. You may notice that I've skipped a little bit of algebra with my SOHCAHTOA here. I'm expecting that you're able to follow this so far. We've been doing this a bunch now. So the next part is I need to look at my vertical components. So I know that my vertical acceleration is negative 9.81 meters per second squared, and I'm looking for my total time. So I can go delta V equals AT. That's the formula I'm looking for. I know my delta V is going to be negative this because I'm slowing down to 0. So I can just put that in, negative 43.30 equals negative 9.81 t. And my time works out to be 4.41 seconds. But that's the time on the way up. In order to figure out my total time, I can do 2 times 4.41, works out to 8.83 seconds. You may be asking, hey, Mr. Sadler, where does that 1 turn into a 3 when you multiply by 2? The answer is, questions like this you have to be really careful with when you're solving them because you can very easily end up with rounding errors. I've left this one in my calculator all the way along. I'm just not writing all of the digits here. So be careful with that as you write in your solutions that you leave your numbers in the calculator so you don't round too early. So that's my total time there. Now, the total time is the only thing that continues on to my horizontal part. So I'm looking for my horizontal, and I can just use horizontal distance is my horizontal velocity times my total time. So I have 25 times 8.83, and that works out to 220.69 meters for my final answer. Now, let's go back and take a look at what we did here. The first thing you may notice what I did is I decomposed here. So I took my initial velocity of 50 meters a second and decomposed it to horizontal and vertical components. This is important because I have to use these separately. So in this case, my first step is decompose it. My second step here is deal with the vertical. So I'm dealing with my vertical acceleration and I'm dealing with my vertical velocity. In fact, I should be a little bit specific. That's my vertical velocity there. And this is to get me my total time. Whole point of dealing with the vertical components is to get your total time. Your total time you then use to figure out your horizontal stuff here. So, just like the previous example, you figure out your vertical before your horizontal. The time is what you're looking for in the vertical, and you use that in your horizontal. With this type, though, we're adding the step of decomposing it first because I have to figure out my vertical and horizontal components of my velocity before I can continue on to figure out the next bits. So far, we've been dealing with only questions where our projectiles have been launched from the same height as they land. The next example, we're going to look at something a little bit more complicated to make this just a little bit more fun. Hope you have a great day.